right, so let's continue with natural deduction. And in this lecture, I want to talk about, there's a few more forms of natural deduction, but a few more rules for it. But in this one, I want to talk about two of the most important ones and one other one that's, important to go with it. And the two most important ones, or two of the most important ones, I think, are rules of natural deduction involving conditionals. And the first of these is modus ponens. I don't know what this means. I did not do well in Latin in high school. My Latin teacher was having a midlife crisis. He did not teach us much Latin. Learned a lot about why he thinks his first marriage failed. I did not learn much Latin. But anyway, I don't know what modus ponens means. I should look this up, I guess, as a good logic teacher. Just Latin logic jargon for this, valid form of argument. If A, then B, A, so B, right? Pretty intuitive, right? If you say, if this one thing happens, this other thing will happen. Well, if the first thing happens, if your conditional is true, the second will, right? You can also think of our truth table. If A is true, the whole conditional is only true if B is as well, right? So once you have A, if the conditional is true, you got to have B. Now that might be super abstract to some of you guys, but look, just let's think of it this way. If it snows a foot or more tonight, class will be canceled. If A, then B. I think I've said this before, it's Hampton Roads. It doesn't even have to snow a foot. An inch will do it, but definitely if it snows a foot or more, we won't have class. We won't have class for a lot of days, right? 2, it will snow a foot or more tonight. A, so B. Modus ponens is not a difficult concept, right? Your conditional in and of itself, your A arrow B, doesn't really get you much at all. But once you get the first part of it, the A, your conditional will get you the B, right? It's always true that if it snows a foot, we won't have class. Most days it doesn't snow a foot, so you can't really conclude anything interesting from this if-then. But on those nights that it does snow, you can make the interesting conclusion of, hey, we all get a day where we don't have class, right? All right. Pretty intuitive, easy peasy, right? What's actually more complicated, and what causes a lot of people more problems, is modus tollens. Modus tollens is another valid form of argument. So modus tollens is, you have if A, then B, not B, so not A. But think of it this way, right? Let's say it is true that if it snows a foot, TCC will cancel classes, right? It is. And let's say that it's some winter night and you don't know if it's going to snow or not. Like we have these weird fronts in Hampton Roads where, we don't know till right the second of when it's going to happen, whether we're going to get a huge snowstorm or just like a kind of cold rain, right? Well, look, if you get up that morning and let's say you had your computer open to the TCC homepage, whatever reason, I don't even have it to the TCC homepage and, I work for them, but let's imagine you did, and you open it up and you don't see that classes are canceled, right? You haven't even looked out the window. You don't need to look out the window. If we have snow, a lot of snow, we will cancel class. Well, from the fact we didn't cancel class, you can safely infer we did not get a foot of snow, right? That's just how modus tollens works. If A, then B, not B, so not A. And you can think of other examples, right? Look, let's imagine your neighbor's really careless with the way he mows the yard, and he's put rocks through your windows, and you wonder, has the neighbor put another rock into my window? Well, if a rock hits a normal window, it will break. Your windows are normal windows. You come home, all your windows are in one piece. It means your neighbor hasn't flung any more rocks with his lawnmower, right? If a rock hit the window, it would break. The window hasn't broken, so no rocks have hit the window, right? another use of modus tollens. You know, or imagine this, right? Imagine you're in a class and your professor had this weird rule of like, well, no matter what your grade is, if you make an A on the final, you make an A in the class, right? Now look, obviously that isn't the only way to make an A in the class. You could make an 89 on the final, and if you had 100 average otherwise, you'd make an A in the class, right? But that is one way to make an A in the class. Let's imagine he has that rule. Well, let's imagine, you haven't gotten your final back. A little harder to imagine in the days of like Canvas when we get our feedback instantly. I still remember when you had to go like to the office and they'd be in piles outside and you had to pick them up, right? Let's imagine you haven't picked it up yet. You don't know your grade on the final, but you open Sys and you see you got a B for the class, right? You know that the professor has this rule. If you made an A on the final, you make an A in the class. Simply from the fact you didn't make an A in the class, you know you didn't make an A on the final, right? Another example of modus tollens. If A, then B. If you get an A on the final, you get an A in the class. Not B, you didn't get an A in the class. So again, you know, given this rule, you didn't make an A on the final. You can also, with modus tollens, you can also kind of convince yourself it's true by looking at a truth table. If our conditional's true, the only line where our conditional's true and not B is true, not A is true as well. But I think the intuitive way is more convincing. All right, so one more valid rule of inference I want to talk about. In this series, we'll learn a few more of natural deduction next time. But the last one I want to talk about today is double negation. Double negation just says, sometimes you'll hear this called negation elimination, and the idea is one negation eliminates another, right? Remember I said, well, the little tilde sign, the not, just flips the truth value of a statement, right? Of a letter or a formula, right? So if A were true, not A is false, and vice versa. Well, another negation, another tilde, just kind of flips it again, right? Well, if you flip something once, you flip it again, it's back in its original position. If you say not, the two nots eliminate themselves. Tilde, tilde, A, not A, so A. There are some really fancy pants logical reasons that get deep into math and stuff that some people have some issues with this. Some people will find this controversial. You can put that aside. Double negation makes life easier, and generally in logic, most logicians accept it. Anyway, so now with all that on the table, let's look back at our little Colonel Mustard argument, right? Colonel Mustard, Reverend Mrs. Scarlet, Reverend Green. Here's the argument. If Colonel Mustard didn't commit the murder, then Miss Scarlet or Reverend Green did it. Neither Miss Scarlet nor Reverend Green committed the murder. So Colonel Mustard did it, right? We have our little key. We have our, formulas in propositional logic. Well, so we can drop all the words because we have the formulas. Tilde C, arrow, parentheses, SVR, close parentheses. Tilde, parentheses, SVR, therefore C. Well, look. We can use our rules that we've learned so far to show that this is a valid argument, right? Tilde C, arrow, SVR. Well, not SVR. We can just treat everything inside the parentheses as one big letter, right? You know, that's what the parentheses basically does. So 3, we get not C by modus tollens, right? If A, then B, not B, so not A. Well, if not C, then S or R, not S or R, so not C, modus tollens. Then we use our double negation rule, and we get our conclusion. This is a valid argument. We've proved it in 4 steps, right? Even here where the truth table method is doable, I hope you can see natural deduction is just way, 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 way quicker. You know, I once heard somebody say that, you know, the best mathematicians and logicians are always lazy people because lazy people had to figure out how to do something in the fewest steps. Well, if you're a lazy person in the long run, natural deduction will serve you much, much better than the truth table method will. I had a roommate who was a really lazy guy, and I did learn some stuff from him. You know, I don't think the guy ever ironed a shirt in his life. It's just like, nah, man, just stick a towel in the shower, throw your shirt in with that wet towel for 10 minutes, and you're good. I mean, I did iron shirts. I still do on occasion. But if you have a wrinkled shirt and, you know, you got to go somewhere pretty quick, that's a pretty good tip. Anyway, that's neither here nor there. But, right, natural deduction, learning these rules, if we want to prove validity, will make our lives a whole lot easier.